For this session, we will continue with the breathing, with the physiology of breathing. So we reach after that session to the respiratory volume. Respiratory volume, it is the amount of air that, or the lung capacity, how much the lung is able or capable to have air inside. So the normal breathing volume, it is which is the active or in each inhalation and exhalation, it is about 500 ml of air which is coming in and out in each breathing. So we call this the tidal volume. So the tidal volume, it is around 500 ml of air that we are inhaling in and out in each respiratory cycle. So it is called tidal volume. Many factors affect respiratory capacity. Some from that, the size of the body build. You know, as a human being, we are having a different size. And also this affects the size of the lung. So there might be variation of lung capacity according to the size of the person. Also, sex. You know that body build of female, mostly it is smaller than the body build of the male. So their lungs also, it might be, the capacity, it might be less than males. According to age, you know, in children, the lung is small. So the capacity is less. It is according, by growing up, the capacity will increase. By aging, sometimes there are some decline of the capacity and the function of the lung, so it might be affected. So, and the physical condition of the person. So all of those factors, it will affect the capacity of the lung. So the respiratory volume and capacities, we have the inspiratory reserve volume. Inspiratory reserve volume. The inspiratory reserve volume, which is the amount of extra air that can be taken forcibly over the tidal volume. So after I inhale normally at rest, which is about 500 ml, I can take a deep breath. So that deep breath, it will lead to full expansion of the lung, complete expansion of the lung. It is approximately 3 liter and 0.1 ml. With 3.1 means 3,100 ml of air that can the lung be capable to hold in a forced breathing after the tidal volume, after the normal breathing. So those who want to dive, they will take a deeper breath before diving because they need more oxygen. Is it clear? So this we call it the inspiratory reserve volume. Inspiratory reserve volume. So after the tidal volume, I can force air inside my lungs, which is about 3,100 ml. the expiratory reserve volume, which is the amount of air that can be forcibly exhaled after the tidal expiration, which is approximately 1,200 ml. After expiration, we said that around the tidal volume is 500 ml, that I will breathe normally in and out in each breathing at rest. So there will be after exhalation, my lung, it will not collapse and it will be completely empty of air. So air is still there. The air which is still there, we have we call it the expiratory reserve volume, which is 1,200 ml, and residual volume. So after normal breathing, there will be 2,400 ml of air are remaining inside my lung. I can expel 1,200 ml forcibly by deep exhalation, by contracting the internal intercostal muscle and diaphragm more. By that, I can get out around 1,200 ml of air from my lung. The remaining will be, which we call it the residual volume, which is around 1,200 ml after forced expiration. So the residual volume of air, it is after most strenuous expiration, about 1,200 ml of air remain in my lung, and it cannot be voluntarily expelled. This is, we call it the residual volume. It will remain inside the lung because the lung will not fully shrink. It will remain inflated with air, with some air. That residual volume, it will allow the gas exchange to go in a continuously even between breathing. So while we are breathing out, the blood will not stop. The blood is running inside our lungs, isn't it? Is it inside the alveoli? So the exchange of gases between our blood and the external or the air which is in the lung, it is continuously. So it will not stop during expiration. Because of that, it is needed to have amount of air inside the lungs in order to have that exchange of gases. Okay? So this, we call it the residual volume. Also, it adds to help and to keep the alveoli inflated. So the alveoli, it has to be always inflated. Otherwise, it will lead to adhesion. If it is completely empty from air, it will lead to adhesion of the alveoli, and after that, it will not be able to work. Okay, did you understand those volumes? So we have the inspiratory reserve volume, that amount of air that I can forcibly inhaled after normal inhalation. The tidal volume, which is the usual amount of air that is coming in and out during each respiratory cycle. Then the expiratory reserve volume, which is the amount of air that I can forcibly expel it from my lung after normal expiration. The residual volume, the amount of air which remain inside the lung and after the forceful expiration. So the total capacity, if we calculate all of those, the total capacity of the lung, it is 6 liters. So the vital capacity is 4.8 liter, or 4 liter and 800 ml, and the total capacity is 6 liter. Why we call this vital capacity? Vital capacity because the amount of air that I can exchange. So because of that, it is called vital capacity. Okay? So the vital capacity is 4.8 liter. The total capacity of the lung, it can hold up to how many liter? The maximum amount of air that can be inside the air at a time, it is 6 liter in an adult. In an adult. So respiratory volume and capacity, the vital capacity, which is the total amount of the exchangeable air. The total amount of exchangeable air that can be exchanged. The vital capacity and the inspiratory reserve volume and the expiratory reserve volume. So it is equal to the tidal volume, the inspiratory reserve volume, and expiratory reserved volume. And it is around 4,800 ml in male. In female, it is less than that. It is around 3,100 ml. Now, respiratory volume also and capacity, there is what we call it the dead space. What we mean the dead space? What's the meaning of dead? Death. So, no life. Here, what's the life of the lung? What's the function of the lung? It is the exchange of gases. So, the life of it is the exchange of air, of gases. So, the dead space, it means that there is an amount of air which is there in an area which has no exchange of air. Because where are the exchange of air happened? In which part of the lung? The exchange of oxygen and carbon dioxide. It has happened where in the lung? What's the functional unit of the lung? I can't hear you. In the alveoli, yes, thank you. So, the amount of air which is there in the alveoli, so the capacity of the alveoli, it is the exchangeable air, isn't it? But when we are taking normal breathing, the amount of air that's coming in, it will come to the upper respiratory tract and the lower respiratory tract and to the lungs. So there are some amount that will be in the trachea and bronchi and the small bronchioles that doesn't have the alveoli. Is there any exchange of gases in those areas? Is there any exchange of gases in this area? No. Because the exchanges, it has to be in the alveoli. The alveoli, it has a very fine membrane that separate the blood vessels or the blood cells from the external air. So the exchange, it will be easy. But in the bronchi and the trachea, there is no exchange. There is mucous membrane, mucous lining, epithelial tissues. So there is no exchange of air in this side. So the dead space, it is there that remain in the conducting zone, and never reach the alveoli. So about 100 ml, 150 ml, it is out of the tidal volume. It is called the dead. It will be in the dead space. So in each inspiration we are taking, normally we are taking around 5 ml, 500 ml. From those 500 ml, 150 ml, they are there in the dead space. So there will be no exchange of air in those, from those amount of air. So the remaining, how much is the remaining? 500 minus 150, the remaining is 350. So 350 ml, it will be in the vital zone. So the functional volume, which is the air that actually reach the respiratory zone, the area that has the alveoli, and usually it is about 350 ml from the 500 ml of the tidal volume. This machine, it is, they are measuring the amount of air. This is spirometer that measure the amount of air in and out, and expiratory volume, and all the what we discussed previously. So, and it will give like an ECG. So it will give diagram like an ECG. It will show the amount of air, or measure the amount of air that is coming in and out. So respiratory capacity are measured with the spirometer. So again, this is the tidal volume breathing. It is 500 ml. 150 ml will be there in the conducted airway, which is anatomically dead space air, that there is no exchange of gases in that area, and 350 ml in the alveolar air, which is the useful air, or practically it is the gas exchange will happen there inside. So again, this is this explains the thing that we explained before. So the upper respiratory tract, nasal cavity, the pharynx and larynx, again we took it, and lower respiratory tract, it is trachea and primary bronchi and the lung. So when we divide the lung to, we divide it to upper respiratory tract and lower respiratory tract. Because of that, always you will hear upper respiratory tract and lower respiratory tract, especially upper respiratory tract infection like throat infection, like laryngitis, and also the lower respiratory tract will came to inflammation of the trachea, then pneumonia, the lower respiratory tract. There are also respiratory air movement, or non-respiratory air movement. So sometimes during those situations there is an air movement, but it is a non-respiratory, like coughing. Coughing, it is, in case of coughing, what will happen? Deep breathing is taken, the gluteus is closed in this after that, and air is forced against a closer, then suddenly the gluteus is open and blast of the air, it will let the air to pass out. So this is during coughing. What's the function of that? The function of coughing is for clearing lower respiratory passage. So it will clear if some mucus is there, or so it will clear it out. It will raise it up in order to split it out of our respiratory system. Then also we have sneezing. When we are exposed to some smells or some allergen, we will start sneezing. So it is the same as coughing, except the air move upward is directed into the nasal cavity by depressing the uvula. So the air is directed toward the nasal cavity. The purpose of it is to clear the upper respiratory passage. So the coughing, it is mostly to clear the lower respiratory passage. The sneezing, it is to clear the upper respiratory passage. Laughing, also, there will be deep breath is released in series of short expiration. So deep breath and series of short expiration will happen during laughing. When it is express happiness. Crying, it is the same as laughing. The thing which happened, it is the same as laughing, but it is expressing sadness. There is hiccup. Hiccuping, it is the diaphragm contraction. It is due to diaphragm contraction spasmodically while the gluteus is closed. It is not known what's the function of the hiccup up till now. عارفين الهيكب what is it؟ شو بتسموها احيانا تحسها ها؟ شو بتسموها؟ سامع شهر يعني ممكن تكون هذه التسمية تبعتهم حازوقة احيانا بسموها لا مش هاب بجوز شغله ثانيه اللي هي الهوبينج كاف yawing تثاؤب. This deep breathing is taken this case there is some hypothesis about it, but it is not a sensible function. Speech, yawing usually if you are sleepy. تثاؤب. Speeching also, during speech, there is, what's the thing that will produce the sound? It is the air which is passed through the vocal cord, through the larynx, causing the vocal cord to vibrate, and also the action of the lips and the tongue, the movement of the lips and the tongue, which will produce the letters and words. So it is for vocal communication, for verbal communication. So it is not from the breathing or non-respiratory air movement, but it is there, and during those situations there is exchange or in and out for the air which is coming in and out to the lung. So a situation other than breathing which move air into and out the lung and may modify respiratory rhythm and change the respiratory rhythm. We'll come to respiratory sound. You will see that if you are going to physical examination, the physician will put the stethoscope in different size and different sides, on your chest from front and from back. He is looking for two sound. which is produced by the by respiratory system. There is sound, those two sounds that we can hear by the stethoscope. We have bronchial sound, which is produced by air when the air is coming in and out of the bronchi and the trachea. So you can hear it at the middle here and this side. So this is called bronchial sound. The sound of air movement in the alveolar side, it is called vesicular breathing sound. Vesicular breathing sound, which is a soft sound of air filling the alveoli. In diseased tissue and the mucus or pus, it will affect those sounds. So the bronchial sound, if it is affected, you give one of the example of that, الشرقية or hoop. So whooping cough maybe due to the change in the upper respiratory or in the trachea and bronchi. So it will give hope, it will give wheeze sometimes. So there will be change, those change in the sound, it depends upon the disease process and the site of the disease process. So this sound, it will be altered according to the condition of the lung and according to the condition of the trachea and the bronchi. We'll come to internal and external respiration, sorry. We have pulmonary ventilation, which is the air move into and out of the lung. The external respiration, which is the exchange of gases between the environmental air and the alveoli, in the alveoli and the blood. So pulmonary ventilation, it is air move in and out, which is the breathing in and out, inhalation and exhalation. So it is called pulmonary ventilation. External respiration, it is the gas exchange between the pulmonary blood and the alveoli. So it is called external respiration. So respiratory gas transport, the gas is transported to and from the lung tissue cells via the blood. The internal respiration, it is the exchange of gas between the blood and tissues. So we have pulmonary ventilation, which is inhalation and exhalation. The external respiration, which is respiration itself, it is the exchange of gases between the blood and the external air, or between the blood and the cells. So between the blood and the external air in the alveoli, it is called the external respiration. So it is happened inside what? Inside which part of the body? Inside the lung, in the alveoli. So it is the external respiration, it is in the alveoli, between the alveolars, in the alveolar sac, between the blood and the external air. So the internal respiration, so gas exchange between the blood and the tissues in the capillaries. So in the capillaries network at the tissues. So In respiratory, we have 5 events, as we said. We have pulmonary ventilation, we have external respiration, and respiratory gas exchange, and internal respiration. So, exchange of atmospheric air in the lung between the alveoli and because each alveoli there is a network of blood capillaries around that sac. So the sac from inside, it is full of air. That air, it contains the oxygen, nitrogen, and all the component of air that is there in our atmosphere, isn't it? Did you remember the concentration of oxygen in the atmospheric air? How much is it? The concentration of oxygen in the environmental air, in the atmospheric air. From biology, did you remember? Your memory is not okay. So it is around 21%. So the atmospheric air, it is containing around 21% of oxygen. It depends upon the level, our level, and the height from the level of the sea. When we are going up, the concentration of oxygen, it will be less. Because of that, those who are living in higher mountains, usually their hemoglobin will be more. Why it will be more? In order to have the ability to grasp oxygen more. So those who are living in the high mountains, high altitudes, they are having more oxygen. When we are going there, we will feel difficulty in breathing sometimes. Why? Because we are not used to the atmospheric pressure there, and we are not used to the low level of oxygen. Did you get the point? Thank you. So, when we breathe in, as we said, the concentration of oxygen in our blood, in the alveoli, inside the alveoli, it will be high. So when we breathe in, the oxygen concentration, it will be high. The blood that is coming to the lung, it's containing less oxygen. It is non-oxygenated blood. So the amount of oxygen there, it will be less. So there is a difference in the concentration of oxygen between the air in the alveoli and the oxygen in the capillaries around the alveoli. Due to that difference, the oxygen will diffuse to the blood and it will be carried by the hemoglobin. So it will be carried by the hemoglobin. The carbon dioxide level in the blood which is coming, the venous blood which is coming back to the alveoli, it is higher than the concentration of carbon dioxide that is there in our alveoli. Due to the difference in the concentration, also the carbon dioxide, it will diffuse to the alveoli. And we are breathing it out through expiration. So the mechanism of exchange, due to the difference of the concentration of air. The concentration of oxygen in the blood which is coming to the lung is less, so it will attract the oxygen due to difference in the concentration, and the pressure of oxygen in the lungs is more, so it will diffuse to the capillaries, and it will be carried by the hemoglobin to the blood. The carbon dioxide, which is coming back, it is containing more carbon dioxide. So the concentration of carbon dioxide is more, so the carbon dioxide, it will go from the blood to the alveoli, and it will be expelled by expiration. So this is in the external respiration. So which is exchange between the lung and the blood. Then the oxygen, it will be transferred to the tissues through the blood vessels, through the arteries, until it reach the tissues. In the tissues, again, there is a network of capillaries. And you remember that the capillaries is formed from how many layers? The capillaries? One thin layer. That one thin layer, in order to enhance the process of exchange. So in the tissue, what's the blood which is coming to the tissues through the arterial capillaries from the side, the capillaries that coming from the side of artery. It is full of oxygen, isn't it? So the concentration of oxygen and the pressure of oxygen there, it will be high. Due to metabolism, in metabolism, the cell will utilize the oxygen there, which is coming to the cell, and use it for its metabolism. And the end product, it will be carbon dioxide. So the level of carbon dioxide is more in the cells, and the level of oxygen is less. So the oxygen will leave the capillaries to the tissues. It will diffuse to the tissue in order to give that tissue that is demand from oxygen. And the carbon dioxide, it will return back to the venous side in order to send it back to the heart and then to the lung in order to get oxygen again. So in the tissues, the tissue will take oxygen and it will take a nutrient also, and metabolism will happen. It will produce ATP, adenosine triphosphate, which is the energy. That energy will be used, and the end product will lead to CO2. That CO2, it will return back to the venous side of the blood, and it will return back to the right side of the heart. Then it will be pumped to the lung in order to get oxygen again. So this is, we call it the internal respiration. So we have external respiration and internal respiration. External respiration, it is the exchange of gases between the alveoli and the lung. Internal respiration is the exchange of gases between the capillaries and the tissues, between the blood and the tissues. The pulmonary ventilation, it is the inspiration and expiration. The respiratory gases exchange, it will happen in both the respiratory transportation of gases, it is through the blood vessels, through the arteries and vein. The arteries will carry the oxygenated blood, and the venous blood, it will return back the non-oxygenated blood. So the external respiration, as we said, O2 move into the blood, O2 loading it's called, and CO2 moved out of the blood. So diffusion of CO2 and O2 between alveoli and capillaries. As we said, the alveoli, it is around it, and there is a network of capillaries. That capillaries, it contain mostly the carbon dioxide concentration will be more, and the oxygen concentration, it will be less, and the pressure of oxygen and carbon dioxide, the pressure of oxygen, it will be less. And here in the alveoli, the pressure of oxygen, it is high, so it will diffuse to the blood vessels, and the blood become oxygenated. This is the external respiration. So the carbon dioxide, it will leave out through expiration, and the oxygen, it will go inside to the blood. It will be exchanged with it. The alveoli always have more oxygen than the blood. The oxygen move by diffusion toward the area of the lower concentration, and pulmonary capillaries blood gain, by that it will gain oxygen. It will take the oxygen. So the blood then will leave the lung rich with oxygen, and the carbon dioxide, it will be poured with carbon dioxide and ready to pump to the systemic circulation. So it will be ready to go to the systemic circulation. This is the external breathing. Again, the gas transport, this is the internal respiration. The oxygen transported in the blood in two ways. We mentioned that also before, that most of oxygen, it is attached to the, most of the oxygen, it is attached to what? To the hemoglobin. So it will lead to oxyhemoglobin. So most of the oxygen, it is attached to the hemoglobin as oxyhemoglobin, and a small amount, it will be carried, dissolved in the plasma. For the carbon dioxide, it is not like this. Mostly it will be in the plasma, and few will be attached to the hemoglobin. So the carbon dioxide transport in the blood, most carbon dioxide is transported in the plasma as a bicarbonate. So it is bicarbonate, HCO3. It will be as a form as HCO3, which is, if you remember the biochemistry, it is as a buffer. What are the buffers? What do we mean by buffers? What we mean by buffers?
Balance of pH. Balance of pH.
Balance, yes. So it is maintaining the balance of pH by changing from highly acid to weak acid, from strong acid to weak acid, or from strong alkaline to weak alkaline. So the HCO3 ion enter the red blood cells combined with the hydrogen ion to form H2CO3. So it will form H2CO3, which is carbonic acid. Then it will, in the alveoli, it will, or when it reaches there, it will be changed to CO2 and water. The water, it will remain inside the blood vessels, and CO2, it will go to the alveoli. So bicarbonate plus hydrogen, it will give the carbonic acid. The carbonic acid, it will give CO2 and water. نعرف اللي هو الحامض زائد قاعدة شو بعطيني؟ ملح ومي. ها؟ هنا carbon dioxide and water. It's CO2 diffused out of the blood. So then the CO2 it will diffuse out of the blood. A small amount, as we said, of carbon dioxide is carried inside the red blood cell on the hemoglobin, but at a different binding site than those of oxygen. So it has different binding site. So the internal respiration, which is exchange of gases between tissues and the cell. Okay, shall we, do you want to take a break?
Yes.
Okay, so I will give you a break, and after that we will continue. Thank you.